All right, here we are back with HaLow-U. I've talked about these adapters before, but in this particular video, I want to not only show the firmware I'm testing for the HaLow-U, but also talk about RF propagation analysis and calculations that I've talked about before. I used in the past Signal Server GUI, so we're going to take another look at that. And the reason why I want to do this is not only to answer some questions people have had about Signal Server GUI recently, well as this 802.11h, but to essentially set up for a future video where I want to have several, three, four of these HaLow-U devices spread out kind of around a lake area that I've did a video at before, and make sure that I understand, or to the best of my ability with the information that I have, provide data into the Signal Server GUI and get a plot, I guess you would say, back that shows, hey, this is the rough coverage area, this is the signal strength, or whatever characteristics that I can figure out. Maybe this is like the budget analysis or the free space path loss, or whatever. So I'm doing a little bit of homework in setting up a network beforehand, from the perspective of, okay, I've added terrain and elevation. Although it's pretty flat, it's not going to affect too much, but you'd want to do that if you're trying to set up two antennas and determine, hey, do I have some obstructions in the way? Am I going to have too much loss between the different stations? And so I figured this time, instead of just jumping right into something real technical, I should probably explain the so what, which that was another thing that was pointed out to me. So I just want to start the video, hopefully lay out a little more clear like why I'm doing this. So anyways, this is the HaLow-U adapter that I have currently, three of them, may be able to get my hands on four, and I am running a newer firmware on it, testing it right now, that changes it from the, you may have recalled in the past where it looked more like an really open WRT GUI. Now it's, I guess this Alfa Networks, this Matrix Pro kind of simplifies it down, does introduce 802.11s for the mesh aspect. Still learning how it exactly works, because right now all three of my devices come up as a mesh point. I would have thought that I could change it one mesh point and then the rest mesh nodes. I may not fully understand that because it just seems to want to stay as a mesh point. I have applied WPA3 encryption on the links, and you can see right now I actually do have uh, a link mentioned here that's been connected over 10 hours, but I do have another one plugged in just here recently that's actually a Pluto SDR, literally just with a blanket on the name, with a Y cable off of it to another 802.11h adapter, HaLow-U, and then battery powered. So it should all be reachable. And if I scroll down, these are the IP addresses, I guess, to all the clients, because I have a couple different computers on each one. Well, three actually. This is a WarDragon that I'm recording on. It has one plugged in. Desktop has one plugged in, and then the Pluto has one plugged in. So I should be able to, for example, let's see, SSH the Pluto, and because I turned it off and back on, let's wipe this key out and do that again. Let's see, analog. Okay, so we're under our Pluto SDR over this 802.11h slash 802.11s mesh network, and I'm pretty certain that Batman Advance, if you look that up, because I can see it as the HaLow-U boots up, I think that Batman Advance which I remember from a long time ago, is being used to make that mesh network possible. The only thing that confuses me is with that, again, back to that mesh AP. Um, I'm not sure how the DHCP is working amongst all the nodes. What is actually controlling that? That's why I thought the mesh AP would have had DHCP, and the other ones, when you try to change it to node, turns DHCP off. But everything seems to be fine now, reaching one device across another. I just was confused, thinking if each provided DHCP, is there some conflict there? But maybe it's something with Batman Advance is actually controlling that. So, anyways, it does seem to be working. So if I scroll back up, a couple numbers that I wanted to work with was this 23 dBm, and then we know our frequency 908.5. All right, so with that in mind, if we remember Signal Server GUI on DragonOS is in the user source Signal Server underscore GUI directory. I do also have under other this DSAM, what was it, the Dragon Spectrum Awareness Manager that I put together, where you can start the Signal Server GUI there, and I covered that in the video. That might make it easy. You can just hit start and it should start it up there. That's fine. I just wanted to go directly into where that I guess you'd say is actually being started. And if we take a look at the README, at the very bottom talks about loading test data, will reinitialize database, all existing data will be lost. So the first time you start Signal Server GUI, if you want to start with some kind of data in there, then you can run this sudo python 3 tacm db.test underscore init within this top level Signal Server GUI directory. Now I've already done that, and I was starting to mess with modifying the existing plot. So I just want to start the Signal Server GUI again. That statement there about 8080 is a little bit false because I've changed it to actually run on just like that Spectrum Awareness Manager mention 8082. So I'm just going to start this manually, and I can see there we go, 8082. And let me refresh this. We'll just come back to the home page there, and you can see now, you can see what's going on in the terminal, which will kind of help identify if there's some issues going on. So with the Signal Server GUI and the database preloaded with some stuff, you already see, hey, I've got some antennas here, and you can dig into antennas a little bit more. As far as the RX gain, you could probably change some of that manually. I'm just going to stick with probably a generic, I think, dipole for this particular example that I'm about to go through. Yeah, I think that should be fine. Let's see. Okay, so we'll stick with that generic dipole, and I want to take a look at some of the existing stations. Test 1 ground level is fine. We can edit that if needed, and I came through here and I stuck in a latitude and longitude that I wanted to look at. I just raised the height some 5 feet, actually maybe, I don't know, a little much. I'm just trying to think of like let's see, probably maybe 3 feet sitting up off the ground. Didn't mess with rotation or down tilt direction. Let's save that. So you really want to have obviously an antenna, and then an area that you're looking at that's going to have your receiver or transmitter set up. So you get that information in, and then the plot you can come here. I'm going to open up the generic dipole plot test 1. Take a look at some of the parameters here. I changed it to plot signal power. Check that. Put in my frequency 908.5. Affected radiated power. So here I was looking at this, and I originally had a little calculator that I put together in Python. Totally had the formula wrong. So looked at it again, and I think I got it now because I wasn't subtracting the 30 there. So if you want, here's the formula and my little function there. And then just to double check, I went online and said, okay, what's the dBm? What's dBm to watts? And this particular rapid tables came up and matched what I was thinking it was. However, DigiKey, I don't know why they got their decimal in a different spot there, so I'm not quite sure what's going on, what the difference is, but we'll stick with this pretty much dot or decimal 2. And just so you know, you really can't put in lower, because this was actually asked. You can't really put in lower than so I'm changing to user source Signal Server underscore GUI. I'll change one more into another Signal Server underscore GUI. And let's take a look at I think it's model, sudo nano model.py, and you'll end up finding that this kind of has some of the minimum, maximum step values that you can set for particular variables within the Signal Server GUI. And specifically, the affected radiated power was at a minimum of 1, I think it was, and so I wanted to go less than that. You also, who knows, maybe your max you can see there. So let's just change this. We'll just change it to a minimum of decimal 2. I'll save that. That way, let's see. Take another look at this. So let's change this to 2. Okay, there we go. So we put in our watts. I didn't change anything else as far as terrain code or any of the climate codes. You could, obviously get into very specifics here. Left the radius out. Didn't change the resolution. The propagation model, I think by default is ITM, but you could change that if needed. And then generic dipole I've got, and the test 1 ground level. Hit save. Now before we really do anything else, one of the most important things, otherwise you're not going to get any good results, is you need elevation data in DragonOS, and I've only included a little sample. So how do we get this SRTM elevation data? Well, the easiest way is this viewfinders panoramas.org. Makes it like super easy. You can go with some of the .gov sites, and then you typically have to have an account to download the terrain elevation data. But here, if you go and you just click digital elevation models, I'm clicking North America, world coverage map. I'm going to grab, let's see, J16, J17, I16, I17. So just simply click on the boxes. It'll download those all to our download directory. They're not typically a very big zip file. So it's downloading those zips, and I tried to make this part easy. And if we go into, let's see, actually it's uppercase, so uppercase Signal Server itself. I left the source code in here and a few scripts that I found online, specifically this. Let's take a look at this get tiles. And so you can see the person that created this left that all in there. Of course, the only thing is I just commented out a few things that we don't need. Just know that the destination, this user source SDF, is where our elevation data is in DragonOS, and this script is going to go through, unzip, rename some files, and then convert them with yet another tool in Signal Server Utilities SDF, so on and so forth. You can look at that script or that binary. Well, if it's not a binary or not, but if it's a script, that is going to convert the map data or the elevation data into the correct format and put it, well, everything's going to get put where it needs to be put. Kind of. We need to do a little bit of work here, and that's going to be a sudo copy WarDragon downloads. I'm going to copy everything that's a zip because I know it's only the elevation data in there right now into user source SDF. Now when I run this get tiles, it should be looking in the user source SDF for anything with a zip. It's going to unzip it and convert it. There'll probably be like some little error that it's going to say. I should look at the script, but shouldn't have taken that long. Let's see. Okay, so let's see. Interesting. Let me kill that script. Now it may be because I had already done this previously. Let me clean it up so it's just like you would have done it. And let's do the sudo copy WarDragon downloads zip to user source SDF, and we'll do the get tiles. Okay, so yeah, there we go. So came through, unzip. Now the only thing I'm not certain is if the subdirectories here would work. So let's just sudo move everything up a directory. There's obviously probably a more efficient way to set this script up and this process. Maybe I'll take a look at that now that I'm using this again, and seeing that it's kind of a little tedious here to get things set up. But so now I end up with my .hgt stuff there. Okay, so now we got elevation data. That is an important part. So now when we come back and we regenerate our plot, it's going to generate it against that elevation data. Although that's kind of bigger than what I had expected. So we can see here what it's actually doing. It's using that SDF directory, and then our watts and frequency and all the information that we fed in is being fed to the Signal Server application under the hood. So now this GUI makes it pretty easy where you can download all your files that it created. Just wanted to take a look at this. So these numbers correlate to the RISI values, I believe it is, on the colors, but we'll take a look at an easier way to understand what those colors mean here when we download our KMZ file. So we got our KMZ file, and we want to take a look at it in Google Earth here. There is another application in DragonOS that you can view your KMZ files, but I just was probably being a little bit lazy here and just using Google. So we'll grab the KMZ and so yeah, this is definitely interesting. So where is our, so if I click on it, bring this down so I can kind of see what's going on here. So it's pretty interesting. So the coverage map, where's this at? No, coverage map. Aha. I went over to Splat and was looking for this particular legend here, I guess you'd say, on the color scheme. I believe that matches within Signal Server GUI. So kind of get an idea of the colors and what those mean as far as power wise, but yeah, again, you got to feed in you know, good information to get a good result. I was looking at, okay, if I set here, what's about, yeah, about a kilometer away. So we're still kind of in the blue here. So 30. So you can kind of get an idea like, hey, like this is going to be my coverage area. And as you move further out, because what it was, it said at like 20K, I think it could go out. This is obviously, where are we at here? Let's see. So we can see as it goes further out, that signal's probably like irrelevant at that point as far as you know, being usable, I guess you'd say, or at a level that is going to allow that connection. I know I was able to connect about a kilometer away. So again, you need the elevation data and information fed in, and then you could probably bounce these numbers off something else, maybe do some real world, go out as far as it's saying and check maybe with some kind of spectrum analyzer or something, like, hey, like these numbers do make sense. But yeah, I just wanted to show running through the Signal Server GUI. Hopefully that made sense. That was a plot in Signal Server GUI with just the particular station. Now you could do a point to point, which I've done in previous videos, but this I just wanted to focus on one particular transmitter receiver and run through again how to use Signal Server GUI, and then a little bit about the 802.11h HaLow-U adapter. So hopefully that helps and makes sense leading into hopefully another video I'll get to where we'll go out and have multiple stations set up. So all right, thank you.